Our purpose in this lesson video is simple and straightforward. We're just going to learn some techniques to cut down the work of constructing truth tables. So we have two goals. First, you should be able to complete truth tables using some shortcuts for getting the truth values of the component sentences. And then you should be able to use partially completed truth tables for testing validity and invalidity. So we'll look first at some shortcuts for the truth values of component sentences. When we determine the truth value under a particular connective, there's some shortcuts that we can use to make the process faster and reduce the number of steps involved in the whole truth table construction. So we'll go through three different connectives that allow us to shorten the procedure a bit. The first is with disjunction. You know that disjunction is true as long as there's at least one true disjunct. That means that if we discover that one disjunct is true, we don't have to actually calculate the other disjunct. So we see an example here below. In the first two rows, we can look at one of the disjuncts, P, and we see that P is true. We automatically know then that the whole disjunction will be true. We don't have to calculate not Q to know that. So that simplifies those first two rows. However, we do have to determine the truth value of not Q in the third and fourth rows. Since P is false, we need to see whether or not the other disjunct, not Q, is true or false to determine the value of the disjunction. So given what we know about disjunction, there are some cases where we can skip calculating one of the disjuncts. The same will apply for conjunction. So think back for the characteristic truth table for conjunction. Conjunction is false most of the time. It's only true when both conjuncts are true. So for conjunction, if we discover one false conjunct, we don't have to calculate the other conjunct. We know that the whole conjunction is false. So here again we have an example. We have P and not Q. And in the last two rows, P is false, and P is one of the conjuncts. So we know that the whole conjunction is false without having to calculate not Q. However, as with disjunction, it turns out we have to do some calculating here. For the first two rows, we have to determine the truth value of the conjunct not Q because P is true. So we need to know whether or not Q is true or false in order to determine the value of the conjunction. And it's false in the first row, but true in the second, depending on the value of not Q. And finally, we have a shortcut for the conditional. Again, remember that characteristic truth table. The conditional is only false when the antecedent is true and the consequent is false. So this gives us two different kinds of shortcuts. One is, if we discover that the antecedent is false, we know the whole conditional has to be true. So if the antecedent is false, the conditional is true. We also know that if the consequent is true, the whole conditional is true. This one's a little bit trickier to remember, but as you become familiar with the characteristic truth table, you might look back on it and see that this makes some sense. For this one, I've given you two different conditionals to indicate these two aspects of the shortcut. Looking at that first conditional, P then not Q, we know that the conditional has to be true in the third and fourth rows, just by looking at the antecedent and without calculating the value of not Q. And that's because the conditional is always true when the antecedent is false. The antecedent is P, and P is false in those last two rows, so the whole conditional is true, regardless of what the truth value of the consequent, not Q, is. Now let's look at the second conditional here. Not P, then Q. In this one, we don't have to calculate not P in the first and third rows. That's because the consequent is true, and the whole conditional is true as long as the consequent is true, regardless of the truth of the antecedent. So as long as Q is true, which it is in the third and first rows, the whole conditional has to be true. We don't have to calculate not P to get those truth values. In the rows I haven't filled in this truth table, you would have to calculate not Q in that earlier column and not P in the later one to finish off the open boxes. Now each of the shortcuts for these three connectives is optional, so use them if you feel comfortable doing so. But if you still feel like you need to write out each and every one of the truth values to feel confident in your truth table, you should totally do so. Now we're going to move on from looking at shortened calculations of the truth values of sentences to not fully filled out truth tables. For background, remember that we learned that the argument is valid. For background, remember that we learned that an argument is valid as long as there's no valuation where the following two conditions hold at the same time. All the premises are true and the conclusion is false. So as long as either of those fails, either there's a false premise or the conclusion is true in that valuation, in every valuation, the argument turns out valid. It turns out that we can determine whether or not an argument satisfies both of those conditions without completing the whole truth table. First, if a line has a true conclusion, it's compatible with the argument being valid. So we don't need to check the premises for that line. In addition, if a line has any false premise, it's compatible with the argument being valid. So we don't need to check anything else on that line. This gives us the following shortened procedure. First, construct the basic framework for our truth table as usual, setting up the right number of rows, filling in the valuations for the simple sentence letters. Then, we determine the truth value of the conclusion on each valuation, skipping the premises and leaving some necessary ones for later. We can check off any rows where the conclusion is true, since we know those ones can't fail our test for validity. Then we need to only look at the rows where the conclusion is false. For those, we go one premise at a time and determine the premise truth value. If that premise is false, that line can be checked off and we don't need to look at any other premises. Let's look at an example to illustrate this procedure. Again, we start by constructing the framework for our truth table in the usual way. We have two simple sentence letters here, so we need 4 rows. And we set up the truth values for P and Q as usual to get all the appropriate valuations. We also have the 3 additional columns. One for not P, one for not P and Q, and the final one for the conclusion, not P and not Q. And again, it's always best to leave the conclusion to the far right for clarity. Once we have our truth table structure and valuations set up in the normal way, we then go straight to determining the truth value of the conclusion on each valuation, here marked in red. And again, we skip the premises for now. Note that if you pause and look at this truth table, I have used our shortcut for conjunction. Since I saw that there was a false conjunct in not P in the first two rows, I knew the whole conjunction had to be false without calculating not Q. Just to illustrate how that shortcut can be helpful. Back to our procedure. Once we've got the truth value of the conclusion in each valuation, we're going to check off ones where the conclusion is true. So in this table, we can check off the fourth row, since the conclusion is true in that row. That means that that row cannot result in true premises and a false conclusion. It won't prove the argument to be invalid. But we have three other rows we still need to look at, because those are ones where the conclusion is false. For those rows, we're going to have to determine the truth value of the premises one at a time, and then we can only check off those lines if we discover a false premise. Scanning over the truth table, I decided to start with the negation of P, and that's because I could easily see that it would make the premise false in the first two rows. So I knew that P was true in rows 1 and 2, so not P would turn out false. Once we have one false premise on a line, we can check off that row. So we can check off the first and second rows. They can't have all true premises and a false conclusion, so they won't prove the argument invalid. However, not P is true in row 3. So for that row, we're going to have to test the other premise as well. And when we determine the truth value of that second premise, not P and Q, on the third valuation, we find out that that premise is also true. This means that this argument has a valuation where there are all true premises and a false conclusion. That shows the argument to be invalid. The upshot of this procedure is that we managed to prove invalidity, and we could have proven validity if this happened to be a valid argument. And we managed to do so while avoiding calculating the truth values in 4 additional boxes. So that saved us some work without compromising our test for validity. And this approach will always work to test validity and invalidity with a truth table. So this lesson has given you a few little techniques for cutting down the work of constructing truth tables. And in the next lesson video, we'll look at one other category of shortened form of truth tables, some one-line ones that can be used in particular instances.